All right. So let's assume you currently own a 2 to 3 year old smartphone and are planning to buy the latest iPhone 15 Pro or the latest Pixel. What if I tell you there is a way to transform the images which you have taken in your old smartphone to look like they have been taken on the latest iPhone, the latest Pixel, or even the latest Samsung Galaxy? Is that even possible? Let's find out. The purpose behind making this video is to help you make a better buying decision. If you are in the market looking for the latest smartphone and camera is something that is very important to you, then this video will be very helpful. In this video, we'll be talking about two techniques, a basic one and an advanced one, to transform an image taken on a Pixel 7a to look like it was taken on the iPhone 13 and vice versa. Not only smartphone camera transformation, but even you can transform the old image into something which is taken by a high-end DSLR. Also, what if you can transform the image from your old smartphone to look like it has been painted by Van Gogh? Yes, even that is possible. Let's check out the results and how to get these results. So the basic or the easier way is to use the script. I will link the GitHub repository as well as the script in the description. You just need to run the script on any free Google Colab GPU or even CPU. Obviously, if you run it on the GPU, it will be quicker. You just need to clone the repository. It is called strots. Then you need to change the directory and you just need to run this Python script, which is strots.py. The first path is basically to the path of your original smartphone image, and then the next path is basically to what image you want it to be transformed. So the smartphone which you want to buy, maybe that. The weight is something which you can change. Generally, we keep it to 1.0. It is one of the parameter in the model. And output is basically the directory in which you want the transformed image to be saved. And device CUDA 0 is basically to use the GPU if you are accessing that. If you are using CPU, you just need to put, instead of CUDA 0, you need to put CPU, but it will be slower. You can use Google Colab free GPU and that works just fine. It will take some time, and in 30 seconds, the transformed image is ready, which you will find in this output directory, which you have mentioned. You can play with this. You can put any image at the start, and then the image you want it to be transformed into, that will be the second path, and you can see how the results are. So this is the easier or the basic method. No need to do anything, no need to install anything. Just go on Colab, or if you have a high-end GPU on your laptop, just run the script and you will get the transformed image. So on the screen, you can see the two original images, and then we'll see how the results using the easier strots basic method are. To the left is the Pixel 7a image, and to the right is the iPhone 13 image. These are the original images captured by that smartphone. There isn't much difference, but if you look closely, you will know what the key differences are. First of all, I would like you guys to pay attention to this footpath. So in the Pixel 7a image, it is a little bit dark and the bricks are more detailed compared to the iPhone 13 image, which is a little bit more bright. Also, the color of the car is a bit different. In Pixel, it is more punchier and more red, whereas in the iPhone 13, it slightly tends towards maroon. Also, the color of the building is a little bit different. In iPhone 13, it is slightly bright and sort of washed out, but in the Pixel, it is more detailed and more true to actual color. I just want you guys to remember these key differences because that is what we'll be focusing on to see when we have transformed the image. And the results of the transformed image using the Strots method are these. If I can open, this is one and this is the second. So to the left is the Pixel 7a image transformed to iPhone 13. You can see that like it was in iPhone 13, the footpath was a little bit bright. The same has been applied to the Pixel 7a image. And similarly, in the right image, which is from iPhone to Pixel, the style of Pixel where the footpath was more detailed, a little bit dark, that has been applied. Also, the color of the building has changed. So you can see these results of the transformed images. Similarly, you can use it for your own use case. One thing to remember is that in this method, you need one-to-one image if you are comparing the two images. What I mean by that is you can see that the same image or the same scenery was captured by both the smartphones. This will help the architecture or the algorithm to understand the pattern, the content, and style of the photo. Eventually, then it will be able to pick up the pattern from that image processing pipeline which the brand uses and then apply it to your original or the old smartphone image which you have. Also, like I mentioned, what if I want to see the old image, how it would have been painted by Van Gogh? So I have some results for that as well. So this is the original image to the left clicked by old phone, which is Pixel 2. And if you reimagine it something like Van Gogh painted, that is the transformed image to the right. It just applies the content and style of Van Gogh's painting Starry Night. So this is a simple basic method. Like I said, you just need to put in the path to your image and then you will get the transformed image in just like 30 seconds. You can try this out. Like I said, you can even transform it into a high-end DSLR camera. Just one thing to note is that you need one-to-one image, so you need to have same shot with two different cameras to get the best output. But in such abstract cases, if you want to apply the Monet painting or this Van Gogh painting style to your any image, even that can be done. So this is the basic or the easier method. And the more advanced or GPU intensive technique is to use this script, which is called cut. Cut is the short form for contrastive unpaired translation. I will again link the GitHub repository as well as the paper, describing this method in the description. You can check that out as well. Also on the GitHub repository, they have the entire README file, which you can follow to get the results as well. In this method, it is similar to the Strots method. You need to git clone the repository. You need to change directory. If you have some packages, then you need to install the requirements.txt file. You need to run the wisdom server, and then you need to train the data on the two images. So you have a source domain image and then you have a target domain image. Source domain will be your old smartphone picture and target domain will be the new smartphone picture. In this method particularly, it is beneficial because once you have trained the model, then you do not need one-to-one image all the time. Once the model has learned the pattern from the target domain image, then it can apply that to any random image. So that is the advantage of this advanced method. Again, you need to have GPU because this is a very intensive architecture which is going to take a lot of time. It has a lot of parameters. You just need to upload the two images, one in the source and one in the target. All this information you will also get in the GitHub repository README file. Once you train the model, it takes several hours, and here you can see on the screen that there are many iterations. Almost there are more than 3000 million parameters. So it will take a lot of time, so you need a good GPU as well. And once you have trained the model on these two images, it will learn pattern from both the images, and then you will get a checkpoint file, basically .pth file, which is the generator file. This you can see the latest net G, that is the generator model. You can use this model basically then to transform your any old smartphone image to look like the smartphone image which you want to buy. You can apply this similarly to Van Gogh style painting as well, what we mentioned in the previous method. So all this is possible. The major advantage of this advanced method is that you do not need one-to-one image like I mentioned every single time. Once you have trained the model, then everything works just fine. You can transform any image to look like the smartphone which you want to buy or the high-end DSLR camera. So this is the advantage, but obviously you need GPUs and it takes several hours to train the model. But once it trained, you can use it on any image. So these are the two methods which I wanted to mention in this video. In conclusion, this transformed image will give you a better understanding of the image processing pipeline used by these different smartphone brands. One thing to note is that the difference between a very old smartphone and the latest smartphone will be huge, and the difference between a smartphone which is just a year or 2 year old will not be that much. Also, the transformed image will give you a better understanding about how the dynamic range is. Is the image more detailed? How is the brightness? How is the exposure? Is the color accuracy according to your taste? This will help you make a good buying decision, and then you can decide which smartphone you want to go with. Thanks for watching, and I'll see you in the next one. Bye.